Hi, I'm John Griesbach with Diamond H2O. Today we're going to be going through a few basic principles when it comes to reverse osmosis systems. First, we're going to go through the checklist that comes in all the manuals of new systems. If you have an older RO system or you've just lost your manual, please contact Diamond H2O so you can have this very valuable checklist. Helps you evaluate whether or not you're having any problems or if you need to do any preventative maintenance for your reverse osmosis system. If you need a copy of this, you can either email us at info@diamondh2o.com or you can call us at 1-800-236-8931. To start, I'm going to turn the RO system on so we can look at a few of the basic parameters. No matter which control you have or what the brand of RO system is, these basic parameters are going to be what we're going to ask for or what we're going to look for doing service and making sure that your system is operating properly. First and foremost, before you even look at your reverse osmosis system, you're going to want to test your water coming out of your water softeners and confirm that your water hardness is 0. Your water should be soft or you're going to have issue with the membrane after a short period of time, which will require either cleaning or replacement. Next, what you're going to want to do is you're going to want to just look at your display. If you have a digital display, some basic things should be on the display. Number one, you should have the temperature. This is important as the membranes are rated for a temperature of water. All specifications are written for a basic temperature. That's 77.5 degrees. As your water gets warmer, you're going to see more water flow through that membrane. It's going to be easier for that water to pass. And your water quality is going to be slightly worse than if the water is cooler. As your water temperature drops, the water becomes more viscous and it takes a little bit more pressure, a little more energy to get that water to pass through the membrane. Therefore, your volumes typically go down and your quality tends to go up. So, you record your water temperature. Next, you have your permeate TDS. This is ultimately the measurement of the quality of the water. It's measured in parts per million, or ppm. What you're going to do is you're going to want to record that number. In this case, it's 3 parts per million. As a rule of thumb, when it comes to spot-free rinse systems or painting processes, we shoot to be under 40 parts per million. Anything above 40 is considered spotting. Some people have a tendency to develop their own parameters, but as a rule of thumb, 40 is where spotting or staining is prevalent, and it's everyone's going to say the same thing, that there's a lot of spots. Usually shoot for under 10 out of a new membrane or out of a new system, but it's all relative to your incoming TDS. So if you need help evaluating the information, please contact Diamond H2O. The last item that you're going to want to record on the controller is your run time. How many hours do you have? This is important so that way you know as your system runs and as you evaluate one site compared to another, you can kind of get a gauge as to how long you go between membrane changes, and you can then therefore do a little forecasting or planning as to how long you're going to get before the next membrane replacement is necessary. Next thing you're going to do is you're going to go to your product flow or permeate flow, it may say on your RO. You're going to want to record what it's at. Next, you're going to have your reject or concentrate flow. This is your wastewater side. And you're going to want to record what your flow meter says for that. You're also going to have a a number of pressure gauges on your RO system. Some ROs have one. This particular one has three. You're going to want to record each individual pressure. You're going to start with your inlet pressure, which is your city water pressure or your inlet pressure after your pre-filter. You have your pump pressure, which is the pressure coming directly out of your pump. Then you have your membrane pressure, which is ultimately the measurement of your pressure in the drain line, so your waste side of things. You're going to want to record all these numbers on day one. This is important so that way as your system ages, you can determine if there's a problem or if there's a potential problem. As numbers change, as your flow rates decrease, as pressure drops increase, those are all signs that maybe your membrane is plugging. Or maybe your flow rates and pressures don't change, but your quality changes. Your parts per million are constantly going up. You're going to want to make note of that because your membrane might be opening up the pores. Reasons that the pores would open up are maybe it's getting chlorine, maybe your carbon filter needs to be changed. So these are all things that they're very important to record, and a lot of times it's just a matter of having the information, whether recorded daily, weekly, monthly. The more often, the better gauge you're going to have as to when a sudden change happens. Say a city decided to flush their lines and your flow rates significantly were affected because the membrane plugged out. You're going to want to know that, and the sooner you catch it, the easier it is to reverse its effects. So, now that you've got everything recorded, the only other thing that you're going to want to do on a monthly basis is make sure you change your pre-filter. We recommend to change the 5 micron pre-filter monthly to help protect the membrane. Not all applications have dirty water, and not all filters are going to be dirty when you pull them. It's a very inexpensive filter, and it's protecting a much more expensive membrane. If you let that go too long, symptoms of that are pressure faults. A lot of people will call us with a pressure fault or a lower water alarm on their RO system and it's constantly shutting down. The majority of that is caused due to the inlet filter not being changed frequently enough, or a large amount of debris getting into that filter and causing it to plug up. Maybe it needs to be changed every week. Depending on the water quality, that's something that's going to need to be determined. However, just make sure that you keep up with that changeout. Next, what I'm going to go through is if you've determined that your RO system is not working properly and it's the membrane that needs to be changed. Well, I'm going to go through that process now to help you just understand how to pull it out, but then also when you get your new membrane in, what to look for. The membranes are directional, so you need to put it in correctly. So that's what we're going to dive into now. The first step of this process is shut off the RO system. There should be an on-off switch. Shut the system down. What that does is it closes the solenoids, gets it so that way we can work on the unit. As a safety precaution, usually what I'll recommend is shut the water off as well. So I'm going to go and shut the water off for this particular system. Next thing I like to do once the water is shut off is on your pre-filter, whether you've got the long skinny pre-filter, you got a big fat pre-filter, they should all have a pressure relief on the top of the cap. And in this case, ours all have a red button on the top of the cap of the inlet. What you're going to want to do is press and hold that button in. You'll get a little water spraying out. If it's in a sensitive area, you're going to maybe want to put a pail underneath it to catch the water. But just hold that in until water stops coming out. That's just going to relieve the pressure on the inlet side. It's going to be before the solenoid, so there should be no pressure on the pump or the membrane, even if you don't have the water off. But you're going to want to shut the water off because typically at the time of changing your membrane, you're also going to change your pre-filter. So now that we've determined the water is off, what we're going to do is we're going to remove the cap on the membrane housing. If you have a fiberglass membrane housing, what you're going to want to do for this particular one is it's got Allen screws. That's the 6mm Allen screw or Allen wrench. So what you're going to do is just take your Allen wrench and loosen up your bolts. If you have any other type, there's all types of membrane housings, stainless housings, even Schedule 80 PVC housings. Really doesn't matter. Even fiberglass, they come in a lot of shapes and forms. Ultimately, they all have caps on them. You're just going to have to figure out how you loosen up the bolts or the clips on the cap itself and just remove that. Now that the bolts are removed, you've got these half moon shaped clips that actually, or plates that actually hold the cap in. You're going to want to remove them. Once you have the plates removed and the bolts removed or the clips removed, what you're going to want to do is you're going to want to wiggle the top. This is where people tend to grow a little impatient. You want to have a little patience. Caps usually have been in there for anywhere from a year to 10 years without being removed. Because of that, they may come out a little difficult and may be hard to break the seal. Be patient. You're going to want to kind of wiggle it back and forth, kind of move it around to try to get this to lift up evenly. Some can be quite stubborn and you may have to try to pry on them or use the bolts and the plates to kind of get some leverage to actually pull straight up on it. However, what we find is just having a little patience, and if you grab onto the hose, you can kind of get a little leverage on it to wiggle it loose. Once it comes loose, what you're going to have is an O-ring here, O-ring seal. We don't recommend to put any silicone or lubricant on this O-ring. There are a few non-oil based products that can be used for this. Typically it's not necessary. If you just wet it down before you put it back in, that's all that's really necessary. So once you get that, you can go ahead and just let your cap hang. If you look inside, you'll be able to see the membrane. There are cases where the membrane may stick to the cap and may actually pull up with the cap if it's been in there a long time. What you're going to then do once you see the membrane, you can actually take I like to use a large needle nose pliers, and you can actually grab onto the permeate tube that's located in the center of the membrane. Most of your membranes should pull straight up with ease. You're going to get a little water, so if you go slow, that'll help prevent emptying the housing of water. What you're going to do is once you get it out of the housing, you can pull the membrane completely out. Depending on the quality or type of membrane that you have, they should come out in one piece. However, in the case of some of the tape wrapped membranes, they've been known, if they're older, to actually deteriorate over time, and they may come out in chunks. This would require you to remove the bottom cap as well to remove the complete membrane. So what you're going to see on this membrane, first off, is that there's an O-ring on one side. In this case, it was down. On the side of this membrane, you're going to see there's an arrow. All membranes should have a directional arrow on them. in this case it says flow direction of feed. What that means is the feed water that's coming in on the outside of this membrane here needs to be going in this side and out the top. Ultimately, what that also means is that your O-ring goes on this side. If the feed comes in the bottom, the O-ring goes in the bottom. Now if you turn it the other way and the feed's coming in the top, your O-ring needs to be on the top. Again, it's always on the same side of the membrane. Okay? This is not necessarily a standard O-ring, it's more of a quad seal. There's a lip inside of it. That lip, or that channel, needs to be in the direction that the flow is coming in. So that way when the flow comes in, it actually will open that quad seal up and make it tighter. So I'm going to slide this back in for now. Now as you slide it back in, kind of work it back in, get the O-ring wet, work it back in so it goes in straight, and that should slide in nice and smooth. What you can feel as you slide in a membrane is if that O-ring were to flip, or that quad seal were to flip, it would then get really tight and be very difficult to push in. That's when you want to make sure you pull it back up, make sure it's straight, make sure it's clean. If for any reason it's not going in or it just constantly wants to roll, just make sure that you wet the housing. Some housings are real rough up near the top. In those cases, sometimes maybe just a little bit of Dawn dish soap even will help. Just lubricate things enough to slide them in. So I'm just going to leave that here. When you order your new membrane, it should come packaged and sealed. In our case, we use dry membranes. The reason we use dry is so that way in the winter you don't have to worry about freezing. It also increases the shelf life of these membranes. Now, as you'll see, if you look at this complete membrane, there is no O-ring on the membrane. Some membranes come shipped with O-rings, majority do not. This is why it's so important for you to identify and know which end of the membrane the O-ring needs to go on. Again, if your flow is coming from the bottom, your O-ring goes on the bottom. If your flow is coming from the top, your O-ring needs to go on the top. Again, following the arrow. If your O-ring is on the top and your flow is coming from the top, the arrow points down. The other items that you're going to find that come shipped with your membrane are going to be your O-ring or quad seal. If you can see here, from the one angle, you've got the channel. The feed water flow is going to be going into and opening up. On the back side of that O-ring, it's flat, it's smooth. And that's what you're going to want to make sure when you slide this onto your membrane housing, that that's in the proper direction. Okay? Make sure that your arrow, in this case it's pointing up, we're going to put the O-ring on that channel in this direction. Alright? If it gets kind of turned in there, just make sure that it's nice and smooth, that it kind of clips into that channel. Pretty easy usually, but they tend to flip over and you just have to kind of maybe pop it out with a small screwdriver. The other item that will come in your package with your membrane looks like this. It's about 1.5 inches long. It's got 4 O-rings on the inside. You can disregard this unless you have a membrane housing that stacks your membranes. This piece goes over the end of your permeate tube. It actually helps you to join 2 membranes together. When you have this size housing, the 4-inch by 40 housing that only holds 1 membrane, this will be discarded and thrown away. So you've got your membrane back together, or you've got your O-ring back on your membrane, you slide your membrane back into the housing, you reassemble your housing. Okay? Again, everything should pop back together. You'll put your bolts back in. At this point, you turn the water back on. Once your water is back on, what you need to do is purge the air out of the system. because you've drained your inlet housing, because you've replaced your filter. It's now partially filled, however, you're going to have air in the system. To do that, what you're going to want to make sure you do is just turn your RO system on and just kind of watch your gauges. Make sure they should be jumping. You see air coming through, you should see a lot of water. If there's an excessive amount of air, just shut it down. You heard the pump try to kick on there. If there's an excessive amount of air, which we could have just let that run. However, if you have a bunch of membrane housings, you want to make sure that you get them all filled with water. It doesn't hurt to shut the system down before that pump kicks on, and just turn it on again. Just to allow everything to fill up, get the air purged out. The more housings you have, the more air you're going to have. Therefore, you just sometimes want to turn it on and off a few times before the pump actually kicks in. Once your pump kicks in, what you're going to want to do is monitor your gauges, monitor your quality. Then we're going to need to adjust our concentrate valve or our reject flow. In this case, our reject valve is actually built right into the flow meter. This is where it's important to know the specs of your RO system and the specifications on your membranes. Because all membranes are not created equal, you want to make sure you know what you're getting, what you're putting in, and what it's rated for, what kind of flow rates it's rated for. In this case, we've got a single membrane. I'm going to flush the air out just by opening the valve up. You can see it adjusts that flow mechanism up and down, or the flow mechanism up and down. This will purge that air out before making the final adjustment. However, this is a single membrane system, so where I'm going to dial this in is about 1.1 gallons per minute to the drain. Never close your concentrate completely, and if you have to turn it down, make sure it falls within the specifications of the manufacturer of either the membrane or the RO system itself. Don't close the concentrate valve to try to get more product flow, because you may get more product flow for a short period of time, but the membrane will plug up quickly if you close that valve. Also, Diamond recommends a certain reject to product flow. That recommendation comes based on having soft water feed. If you do not have a water softener feeding your RO system and your water is hard, you're going to significantly change the reject flow, ultimately making your system less efficient. In this case, a one membrane system is 1.1 gallons per minute. Our product flow on this brand new membrane is coming out to be about 2 gallons per minute. What you're going to want to do at this point, you've purged the air out, you've set the flow meter. You're going to want to take your checklist. Hopefully you have a new undrawn on copy, and you're going to want to record all the data. You're going to want to record your inlet pressure, pump pressure, membrane pressure, concentrate flow, permeate flow, water temp, your product TDS, your parts per million of chlorine coming out of your carbon filter, which should be 0, your incoming hardness, so ultimately how hard your water is coming into your softener, the water coming out of your softener. You've got on here tank 1 and tank 2. If you've got a 2-tank system, you're going to want to validate that both systems are indeed working. Then we have a spot on here to sign who tested this, so that way it gives some accountability to whether or not this was done and who did it. There's also a spot on here for when the filter was changed. Typically, if you fill out one of these sheets monthly, you can have a good log of what's going to be going on with your system. And as long as you record your quality on day one, I would transfer that to every sheet for every month that you have going forward. What this allows you to do is to see change. As qualities change, as flow rates change, as pressures change, you can then ask questions as to why. And a lot of times you can create a means of correcting a problem before you actually have a mechanical failure of a membrane or of a pump. So this checklist allows us to help determine not only what's going on the day that you have the problem, but maybe what was going on that led up to the problem. The more you fill out, the better off you'll be. So to wrap things up, if there's ever any questions regarding what we've talked about today or the Diamond checklist, please contact Diamond H2O.